Linear regression part 2. In the previous video, part 1, I showed you how to set up this scatter plot. Now we're going to use this scatter plot and the data in the scatter plot to find an equation that best models the situation using the calculator. And this is known as the line of best fit. Okay? So we want to find the equation of the line of best fit, and then we're going to use that information for parts C and D down here. So using your scatter plot, we need to basically access the data from the lists and then create an average trend. That's basically what the line is doing. If you can imagine, you don't draw this on your calculator, you can imagine a line going through the data points that represents this trend. The line is an estimate. It's not exactly the relationship between every single data, because every single data, if you connected every single data point, you would end up with like kind of a zigzag curve type line. So it's not exactly, but it's a good representation of it. Okay, so we're still working with the lists and the data tables, and so we're going to still use stat, which is S-T-A-T, but instead of using edit, we're going to go to calc, because we want to calculate the linear regression, which is down 4. And you can either click 4, or you can scroll down to 4 and hit enter. Now it's going to come up with this. Remember, those of you who have a little bit different of a calculator, a newer calculator, you're going to end up with a menu, and you can go straight down to that. If you need help from this point with the new calculator, you're going to have to come in, because I don't have enough time to do a video especially for you. Alright, so basically what you want to do is you want to make sure that you take the linear regression of the two lists that you have data in. In our case, list 1 and list 2. So, second 1 will give you list 1. You can see a little L1 above the 1. Then, comma. Always put a comma in between every single character. Second 2 will give you L2, comma. Now, this is where the people with the other type of menu will want to put it in. You already have list 1 and list 2. In the equation part of your calculator, or in this case, right here after the comma, we want to tell the calculator to take this information from list 1 and list 2 and write an equation that represents it, then put that equation into the Y1 slot. So we're going to hit the VARS button, VARS. It's going to give us a menu. We want to go to YVARS, and then we want to choose the function, and then we want to choose Y1. Now when I hit enter here, I know I was successful when I get y equals ax plus b. If you have a different type, you want to go down to, scroll down to calculate, make sure that calculate is highlighted, then hit enter. So we have the linear regression here, and we have the A, which represents our slope 2.41, and our B 41.65, which represents our y-intercept for the situation. And look, we have it into our y1. So if we were writing this down, we would estimate this as y equals 2.42 x plus 41.65. Okay. You don't have to write down every single decimal point the calculator gives you. Just estimate to the nearest 100th place. Now we're going to use this equation, and we're going to find a value for the input of 15, or, in terms of the situation, estimate the number of patents issued in the year 2000. So, this means we have an input and we need to find the output. Second trace will give you calculate, and we're calculating the value when x, or in our case t, is equal to 15. This is why we need it in the window for 15 to be in this window. If it wasn't, it wouldn't have calculated it. So here we have that the y is 77.9. So the number of patents issued in 2000 was about 77.9. So I wrote the answer in terms of situation. Important to do that. Next, we're going to find the year in which 80 patents were issued. So to do that, you need to go back to your Y2, and we're going to enter in the value 80 that we need to find the input for. We're going to find the intersection of these two equations. I'm going to show you what the graph looks like. Here you can see that when I hit graph, look, you can't see the intersection. Do you want to know why? Because it's not in the window. Go back to the window and increase the Y max to incorporate this value here. Now when you graph it, you can see the line represents and the intersection is still not there, so we still need to increase a little bit. So we're going to go to the window. We're going to increase our X max to 25. Now we have the intersection on our window, and so when we calculate the intersection, the calculator will find it. Second trace, which gives you the calculate menu, intersect. You're asked for the first curve, is this, yes. The second curve is this, yes, enter, guess, yes, enter. And the intersection is 1586. So in the year which 80 patents were issued is 15 years. It's almost 16 years, so you can say sometime in the end of year 2000.